Today, we're diving deep into the shadows of the digital world. We're going to put on our detective hats to hunt down some of the most elusive criminals out there, malicious software. So, how exactly do you catch a ghost in the machine?
Well, that's the million-dollar question for digital investigators, isn't it? Their job is to track down malware that's literally designed from the ground up to hide, to steal, to damage, or even take complete control of everything from our personal computers to critical national infrastructure. It is a super high-stakes game of cat and mouse, and a single wrong move can be absolutely devastating.
To really understand the hunt, first, we need to get to know our prime suspect. And in this digital crime scene, the culprit, every single time, is malware.
At its heart, malware is just any piece of software written with bad intentions. I mean, it can be something as kind of simple as an annoying pop-up that just won't go away, or it can be a crazy sophisticated state-sponsored tool designed for international espionage or massive financial crime.
And malware isn't just one thing. It's a whole ecosystem of digital threats. You've got Trojans, right, that trick you by pretending to be legitimate software. You've got viruses that latch onto other programs to spread themselves. And, of course, there's the one everyone's heard of, ransomware, the stuff that holds your most precious data hostage.
The best way to think about malware is that it's assembled from a criminal's toolkit. So a dropper might be used to silently sneak the main package onto a system. Then a packer compresses it, kind of like a digital Trojan horse to get past antivirus software. And the payload? That's the final blow. That's the part that actually does the damage.
Okay, so the worst has happened. A system's been hit. An alarm goes off. How do our digital detectives actually start their investigation? What's their playbook look like?
This whole field is called malware forensics. And you can think of it like digital archaeology. The entire goal is to carefully dig through all the code and the system files to basically reverse engineer the crime. You're trying to figure out who did it, why they did it, and just how bad the damage really is.
Now, investigators have two main ways of tackling this. The first is called static analysis. This is like examining a disarmed bomb. You study all its wiring and its components without ever letting it go off. The other way is dynamic analysis, which is the exact opposite. You actually detonate the bomb, but in a controlled, safe environment so you can see exactly what it does. So let's start with static analysis. This is all about looking at the clues at the crime scene without disturbing a thing, just observing what's there. First things first, you've got to get an ID on your suspect. So an investigator calculates what's called a hash value. It's like a unique digital fingerprint for that file. And then they run it against these massive online databases of known malware. Sometimes you get lucky and find a match right away, but a lot of the time the malware is brand new, and that's when the real detective work has to begin. Next up, they start sifting through the code for any readable text, which analysts call strings. And this part can be an absolute goldmine. You might find a web address the malware is supposed to contact, or a specific file it's looking for in your computer, or maybe even some comments left behind by the creator themselves. So let's say you've got a suspicious email attachment. The process is a pretty clear three-step method. First, you identify if there's a hidden script in there. Second, you isolate exactly where that script is hiding inside the file. And third, you extract it and read the code to see exactly what malicious instructions it's trying to run. But see, static analysis only tells you what the malware could do. To see what it actually does when you run it, we have to move on to dynamic analysis. This is where investigators take the malware and put it into a digital interrogation room. It's often called a sandbox or a virtual machine. And it's basically a completely isolated copy of a computer system where the malware can run totally wild, without any risk of it escaping and causing any real damage. So once it's running in that safe box, an analyst might use a tool like Netstat to see what's happening on the network. And boom, that's where they might spot the malware phoning home, making a connection to some suspicious external computer, which is probably its command and control server just waiting for new instructions from the attacker. You know, malware doesn't want to run just once. It wants to be persistent. It wants to survive a reboot. So investigators will check the computer's scheduled tasks to see if the malware has burrowed in, creating a little entry for itself so it can launch automatically every single time the computer starts up. Sneaky. Okay, enough theory. Let's put this all into practice. We're going to apply these techniques to a real-world villain that has caused hundreds of millions of dollars in damages, the Black Cat ransomware group. A Black Hat attack is just a methodical, devastating campaign.
It kicks off by sneaking in with a disguised loader that hides itself in the computer's memory. Then it starts scouting the network like a predator, hunting for powerful administrator accounts. And then, in this really cruel twist, it steals your most sensitive data before it locks anything up. And only then does it start encrypting every file it can find, basically sealing your digital fate. And here's the knockout punch. This single, simple-looking command is often the most destructive step of the whole attack. It uses a standard Windows tool to delete all the shadow copies, which are the system's own built-in backups. With this one line of code, the attackers vaporize the victim's easiest path to recovery. They are tightening their grip.
And after all of that technical complexity, the droppers, the exploits, the evasion techniques, it all comes down to this one single thing: a ransom note on the screen, leaving the victim with that terrifying feeling that they have no other choice but to pay up.
The Black Cat case is a perfect and scary illustration of this high-stakes, constantly evolving battle between the attackers and the defenders. And it leaves us with a really critical question for the future. As these digital ghosts get smarter and faster, what new tools and techniques will our digital detectives need to keep hunting them down?